Last time we built ratios between numbers. Now we do the opposite move. Take one smooth number, tenure, and chop it into buckets. Why throw away precision on purpose? Because the relationship isn't a straight line. Churn doesn't fade smoothly month by month. It drops in steps. New customers leave a lot, long timers barely leave. Bins let even a simple model see those steps. First flavor, fixed edges. We pick boundaries that mean something to a human. Under a year, 1 to 2, 2 to 4, 4 to 6. With Pandas cut, the edges are our choice, the same on any dataset, nothing learned. Second flavor, quantile bins. Here we ask for 4 buckets with the same number of customers in each and let the data decide the cut points. On our training tenure, the learned edges land around 9, 29 and 55 months. And that's the catch that makes this a hygiene episode. Those quantile edges are learned, so they are fit on train only. We then transform the test set through the same train edges. Recompute them on test and you've peaked. The test buckets would no longer reflect what the model was trained on. Here's the whole thing in one file. Fixed bins with cut, learned quantile bins with k-bin discretizer fit on train. Load and drop the ID. Split train and test, stratified, random state 42. Fixed edge bins on tenure with Pandas cut, 4 human named buckets. A k-bins discretizer, 4 quantile bins, fit on train tenure, then transform test with those learned edges. Churned by quantile bin on train falls cleanly across the buckets, about 50% in the newest down to single digits in the oldest, and the test counts come out even, proving the train edge is transferred. Bins tamed an uneven column. Next we tackle skew itself, a long tail like total charges, and squash it with log and a power transform fit on train. If this helped, like and subscribe for more.